Right, class. Good evening. Assalamu alaikum. Right. Let's continue with our lecture today. Still under chapter number 4. Right. Chapter number 4 is classification method. So last class we already looked at logistic regression. Right. Remember? Still remember logistic regression. So what is logistic regression? Logistic regression is we want to find relationship between two variable, right? At least one independent variable, at least one independent variable and one dependent variable, and the dependent variable should be categorical variable with two levels, right? So basically, we want to classify whether independent variable lies in. So it's the same concept. So overview. So introduction to deterministic and stochastic model. I think this one I already introduced you last class. What is a deterministic model, stochastic model, generative model, and discriminative model, right? And then we're going to look at law of probability. We're going to learn some probability techniques, but not really learn. We just want to revisit the theory, right? And understand the naive Bayes classifier. Right. So I think this one I already mentioned previously. Deterministic model means a system which no randomness when we input the data, and the output data will be the same based on the input data. No randomness involved means that if you run a model without splitting data into training or testing set, right? And then stochastic model means where the randomness involved, we split the data between testing and training set to get output, and every time we split the data, the output might be different, right? It's not going to be same as deterministic model, right? So this is just an illustration, the relationship between deterministic and stochastic, right? So now, many classification problem involve uncertainty. Means in logistic regression also we involve uncertainty where we don't know the distribution of the data, right? So one of the problem is the observed variable and outcome label may be unreliable due to imperfection in the measurement process, where we collect the data, maybe the sample size is not sufficient, your sampling technique is not accurate, and maybe whether a person, what is the risk of a person getting heart disease and no heart disease. So maybe I involve two independent variable, diet and workout frequency. Maybe this model will give accuracy more than 80%, but as a whole, maybe this model is not really representative the heart disease because we did not counting the appropriate variables such as inheredity, excessive smoking, right, and alcohol abuse, right, which is this is not involved in the model, right? So this is might be a problem for classification, right? Now, a classification model learned over a finite training set may be not be able to fully capture the true relationship. This is there is a need to not only make a prediction of a class label, but also measure the confidence associated with every prediction. Means we need to know what is the value of accuracy, sensitivity, and specificity. I think I already mentioned this in previous topic, logistic regression. When you have performed a model, then you need to measure the confusion metric, means the prediction value versus outcome value. From there, we can calculate the accuracy, sensitivity, specificity, and F measure. Right. So this is the thing that we want to focus in this topic, which is the probability theory. Probability theory offers a systematic way for quantifying and manipulating uncertain data. In fact, in previous topic, we also learned probability, but I'm not really emphasized to probability part last class, right? Where we want to find the probability of Y given X. That means we want to find the probability of Y given that X is already happened. So classification model that use probability theory to represent relationship between variable and outcome variable known as probabilistic classification model, right? So the model that not utilize the probability theory is not a probabilistic classification model, right? Such as a tree diagram and so on. So naive Bayes is the simplest and most widely used probabilistic classification model. If you still remember the probability theory, probability of X, conditional probability, Bayes theorem. So we're going to apply Bayes theorem to the classifier. So the basic knowledge that we need to perform naive Bayes classifier, we need to know the law of probability, conditional probability, and Bayes theorem, right? Okay, boleh? So law of probability, let's look at the first, revisit the probability law. I think you already learned this one previously, right? So probability of event, let's say an event is X. The probability of event X is calculated by number of event or outcome in X divided by total number of outcome. Number of outcome in X divided by total outcome. So this is the probability of X. So probability, normally with the symbol of probability PX, or some books we put it as PRX or intersection formula is a symbol for intersection X and Y is X intersect Y, is the number of outcome for both X and Y divided by total number of outcome. Right? Can you understand this one? Very simple, right? So if two events are independent, X and Y are independent, so probability of X intersect Y will be equal to probability of X multiplied with probability Y. So we're going to use this concept in naive Bayes classifier. So when you have probability of X multiplied probability Y equal to probability of X intersect Y, so means that X and Y are independent, even it's not related, right? If X and Y are dependent, right? So we are looking into a conditional probability. Conditional probability, probability of X given Y, it means that it's pronounced by probability of X given, this is stroke given Y. It means that we are interested to find the probability of X given that Y is already happened. Right. For example, let's say you go to one restaurant and you promote that restaurant to your friend. So we want to know what is the probability your friend will go to that restaurant given, provided that the information you give to your friend. This is a simple example I can provide for you. So this is probability of X given Y means the probability of X intersect Y divided by probability of Y. So whatever happen will be on denominator, right? So let's say another example, probability of y given x, it should be probability of x intersect y divided by probability of x. And probability of x intersect y is also equal to probability of y intersect x. It's the same thing, right? So if x and y are independent event, so probability of x intersect y will be equal to probability of x given y multiplied with probability of y. So how do I get the formula? So simply adjust this formula, like denominator go to our left hand side, so we get probability of x, probability of x given y multiplied probability y. It's also same as probability of y given x multiplied with probability of x. It's the same thing. This one I got it from conditional probability. Okay. I hope you're clear about basic probability theory. So the next thing that we need to know is a Bayes theorem. So Bayes theorem is the same concept as conditional probability. The only difference is where we have many value of x, right? So for example, this is what we call as posterior probability, and this is our class conditional probability, and this is what we call marginal, right? This also can be interpreted as probability of x given y multiplied with probability of y divided by probability of x, right? So probability of x is equal to the summation of intersection with x, right? To understand this, let me draw one lake lah. Let's say this, assume that this is a lake, right? So where we have a lake here, this is Lake A, and this lake shared by 3 main districts. So let's say this is District 1, District 2, and District 3. So if you want to know, you want to calculate A from this diagram, so how are you going to do that? You're going to add all the intersection. Let's say we take this one, intersection X1 and A, and this one is intersection X2 and A, and this is also the intersection X3 and A. So if you add X1 intersect A plus X2 intersect A, and the last one X3 intersect A, you will get A. Right? Do you agree? Agree, right? So this is what represented by probability of x, where x is everywhere, right? We want to find where x shared by y, so we want to find the value of probability of x. So we need to add all the intersection with x. Okay. So this one can be interpreted. This is the Bayes theorem, can be interpreted as probability of y given x equal to probability of x given y multiplied with probability y divided by probability of x given y. This is a y1 lah. This is yi, y1, y1. So probability of x, this is probability y1 plus probability of x given y2 multiply probability of y2. Right. So basically it came from conditional probability. Right. So if you understand the conditional probability, then for Bayes theorem should be no problem at all. Okay. So this is some law of probability that you need to know. As I mentioned in logistic regression, right? The odds of an event, odds the chance is starting from 1 to infinity, but probability start from 0 to 1, right? So probability of event should lies between 0 and 1. This is the first rule of probability. Equal to 1 until n, where it is in the under same sample space, it should be equal to 1, right? So the summation of all probability should be equal to 1, and probability should lies between 0 and 1. This is the rule of probability, right? And the last one, and since the summation of all probability equal to 1, if you want to find a complement of event A, let's say you want to find complement of event A, sometimes in some book we'll put it as AC. It's the same thing, complement. It means that 1 minus probability of A. So because the total of all probability equal to 1, if you want to find the complement, should minus by 1, right? Okay, so far, any question regarding law of probability, conditional probability and Bayes theorem? No? Okay, good. Right, basically conditional probability is a likelihood of outcome occurring based on the previous outcome occurring, right? Outcome that happening based on previous outcome that happened. Right. Bayes theorem provide way of revise existing prediction or theory. Means that we want to find in other way. Let's say we want to we can get the probability of x given y. Now we want to find probability of y given x. So this is our objective. We want to find probability of outcome given that the independent variable. So this is the same concept based on logistic regression. We want to find probability of y given x. Okay, so I think I already mentioned this one. This is what we call as posterior probability. This is a class conditional, and this is marginal, right? So we are interested to find the posterior probability given that class conditional and marginal probability. Now, let's look at Bayes theorem. Try to understand what is Bayes theorem. Okay, let's look at this example. I think I already provide the answer in the slide. Have you downloaded my slide? Sudah? Right. Before that, don't forget to sign in your attendance. Right. Sudah? All right, good. So a doctor knows that meningitis causes stiff neck 50% of the time. So it means that this is the probability of stiff neck given meningitis. So we know that meningitis already happened. What is the probability is cause stiff neck should be equal to 0.5. So this is the value that we know. The prior probability of any patient having a meningitis, so this is the probability of M, is 1 over 50,000. So if a person don't have meningitis, should be 1 minus 1 over 50,000 lah, right? So this is a complement, okay? So prior probability given as patient have a stiff neck. So this is a probability of stiff neck equal to 1 over 20. Patient who did not have stiff neck is 19 over 20. Okay? So if you want to find a patient with stiff neck, we want to find the probability that a patient has a meningitis given that he has a stiff neck. So it means that probability of, we know that he already had a stiff neck. So we want to know what is the probability that he also have a meningitis. So this one should be probability of M intersect S divided by probability of S based on conditional probability, right? So if you can expand this one, we know that probability of M given S is equal to probability of, so let's say we make it a reverse. Probability of S given M is equal to probability of M intersect S divided by probability of S. So this one should be probability of M intersect S should be probability of S given M multiplied with probability of S. So we want to manipulate this value because we all know that probability of S, we know probability of S given M. Right. So we want to find probability of M given S. So this one should be also equal to probability of S given M multiplied with probability of S divided by probability of S. Okay. Sorry, this is multiply with M, right? Because the denominator is, this one already happened, right? M. So this one multiply with M. So probability of S given M is 1 over 50,000 multiply with probability of M is, this is probability of S given M is 0.5 multiply with probability of M 1 over 50,000 divided by probability of S 1 over 20. So this one should be equal to 0.0002. Right? Okay. Just an introduction to Bayes theorem. Not yet knife classifier. Okay. So we will apply this concept. Let's look at the second example. So I think I already provide the answer, can? Maybe I will explain to you in another way. So let's consider a problem which inferring whether Alex will come to the party. Let's say Alex come to the party is equal to A equal to 1, right? Denote that Alex going to party. A equal to 0, not going to party. Let's say A equal to 1 equals 0.4, A equal to 0 is 0.6. So let's draw a tree diagram to illustrate the situation. Let's say this is the probability of A, this is the probability of A complement. A means the probability of Alex going to party 0.4. Not going to party 0.6. Should be the probability of Martha going to party is 0.8. And this is going to be 0.2. Okay. So when Alex not going to party, Martha going to party is 0.3 and the balance will be 0.7. So we wish to know what is the probability of Alex going to party, right, given that Martha also going to party. That means I think better I put it this way, A given M. And from the tree diagram, we know that this is a probability of A. This is also probability of A complement. And this is a probability of M given A. If you want to know what is the probability Alex going to be going to party, given that Martha also going, right, means that we know that Martha is going. So we want to know what is the probability Alex also going. So by applying the conditional probability or naive Bayes, Bayes theorem, probability of A intersect M divided by probability of M. Right. This one we can expand by probability of M given A multiply with probability of A divided by probability of M. So how to get probability of M? Remember the leg I draw just now? So M is shared at the first tier, and the second tier also have M. So we need to add all the intersection with M. So this one should be equal to probability of M given A multiplied with probability of A divided by probability of M given A multiplied with probability of A plus probability of M complement. Sorry, I think M given A complement multiplied with probability of A complement. Yeah. So then we can get the value of M. So basically we are looking into the intersection between M and A, M and A complement. So this one should be equal to, you just take the value lah, probability of 0.6 multiplied with 0.3, this one. Right? So this one should be equal to 0.64. So since the value, we learn in logistic regression, if the cut point of probability is 0.5, right? When the value of probability less than 0.5, we will classify as 0. If the value of probability more than 0.5, we will classify as 1. So in this case, 0.4 means that Alex will highly likely to go to the party, given that Martha also going. Okay? Understand? Okay? Any questions so far? Done? This one done, right? Okay. Let's look at next example. Example number 3, where we want to know the probability of strike. The completion of construction job may be delayed because of strike. The probability that will be a strike is 0.65. The probability that construction job will be completed on time if there are no strike is 0.75. So now, based on the first information, there will be two possible outcomes. Either there is a strike or no strike. Right? Probability there will be a strike 0.65, no strike 0.35. Given that there is no strike, right? No strike. This is no strike. Complete on time. Complete delay. Complete on time is 0.75. Delay will be 0.25. This condition also repeat at the strike. Complete on time, complete the delay means the probability that construction job will not be completed on time, not completed on time if there is a strike is 0.65. Complete on time, strike 0.35. So what does it mean? This is the value of probability of S. This is probability of S complement. This is probability of C complete on time given that strike. Complete on time, not complete on time given strike. Complete on time given no strike. And this is delay. So delay and no strike. Okay, so we want to know the probability. We know that the job cannot be complete on time. Right? This is the first information we know. we know the job cannot be complete on time. We want to know what is the probability that will be a strike. So based on tree diagram, based on conditional probability, so we want to find probability of strike given that job is not going to be on time. So this one based on conditional probability, probability of S intersect C complement divided by probability of C complement. Right. So probability of S intersect C complement should be here, right? Right. So this one should be probability of C complement given S multiplied with probability of S and divide by probability of C complement. So we know that C complement is occur in strike and no strike. So we need to add all the intersection with strike and no strike. So this one should be probability of C complement given S multiplied with probability of S plus probability of C complement given S complement multiplied with probability of S complement. So input all the value into the formula. Say this color. So this one should be 0.65 multiplied with 0.65 divided by 0.65 multiplied with 0.65. This is the same thing plus 0.35 and 0.25. So this one should be 0.8284. So there will be a high chance of a strike. Okay. Any question? Easy, right? It's okay. Because after this linear discriminant analysis, we will apply the same concept. So you need to understand the Bayes theorem. Right, so this is the answer. So now let's look at naive Bayes classification. So naive Bayes classification, we are interested in computing probability of observing class label for data observation given its set of variable values. So as I said just now, we are interested to find probability of Y given X. Instead of calculating X given Y, we are looking into probability of outcome given independent variable. So this is what we call as posterior probability or the target class. Right. So again, this is posterior probability. This is a class conditional. This is marginal. So marginal probability. Okay. Boleh? Question? No question? Hey, come on. You understand, right? Okay, good. Now, I thought we can finish by 6 o'clock, but I think cannot. Now, naive Bayes. Naive Bayes assumption, this is a classifier that we are looking, is apply a Bayes theorem. So naive Bayes says that assume that class conditional probability of all variable X can be factored as a product of class conditional. It means that when it can be factored as a class conditional, remember probability of X intersect Y equal to probability of X multiplied with probability Y. Remember this term I introduced you just now? This is where X and Y are what? Independent, right? X and Y are not related, means independent. So means that when it assumes class conditional can be factored as a product of class conditional, means that it's assumed that class that variable X is X and Y are independent. The class conditional are independent. So the variable of xi are conditionally independent of each other given the class label y. It means that the variable are influenced only by the target class, and if we know the class label, then we can consider the variable to be independent each other. So conditional independent, I think I already explained just now, means that probability of x give an intercept. Now let's look at example number 4. So we have a data, we want to apply a 9 Bayes. I think we can finish by 6. And we can continue linear discriminant after that. So we have 4 variables. 3 variables are categorical. Betul? 1 variable continuous. Right? Which one is categorical variable? Which one is qualitative variable? Categorical means qualitative lah. Qualitative variable, which one? Homeowner, marital status, default borrower. Right? This is a qualitative variable, and continuous variable is annual income. I think silap soalan I dah tulis sini. Alright. So lepas ni I tak tanya yang I tulis dah. Okay, now. So we want to predict the loan default problem. So before we execute with the naive Bayes, let's try to narrow down by doing cross tabulation table for each of the qualitative variable. Let's say we are looking into qualitative variable first. And in this case, y is default borrower. This is x1, x2, x3. This is independent variable. We want to predict whether a person who had a house, married, annual income this much, what is the possibility he is a default borrower, yes or no, right? So in this case, we try to make 2 by 2 table. Let's say this is 2 by 2 table for home owner. Right, let's say this is home, this is default. We have yes and no. Right. So let's say this is no, yes, total. This is no, yes, total. So let's focus on the first part, which is home borrower is no. So this is the first one. Second, third. So that's why if you have a highlighter, then it's good lah. Bring in test and final exam lah. So how many no? So the total observation, capital N equal to 10. So probability of y equal to no is equal to 7 over 10. Right? Remember? Definition of probability, number of event divided by total number of event. So 7 is no divided by total number is equal to 10. This is 0.7. Probability of y equal to yes should be equal to 0.3. It's a complement of 0.7. Right. Now, if the home default, homeowner is no, so number of no is 1, 2, 3, 4. So we have 4 no, default no, homeowner no. And we know that the default no is equal to 7. And this is equal to 3, then 10. Right. So default yes, homeowner yes is 1, 2, 3. So 3. Right. Okay, this one clear, right? So we just want to find number of outcome. Later on, we will calculate the value of probability. Let's say we are looking into yes. Default borrower, yes. So here the number of homeowner no is 1, 2, 3. So we have 3. And number of homeowner yes, 0. Right? So this is 7 and 3. And from here we know that n default equal to yes equal to 7. 3. And default equal to no equal to 7. And homeowner equal to no, right? Intersect with default equal to no. How much? Homeowner equal to no, default also equal to no, equal to 4, right? Homeowner equal to yes, intersect with default equal to no, should be 3, right? So NH equal to yes, intersect D, this one, yeah, we follow the flow, and no, intersect D equal to yes. This one should be equal to 3, and H yes, intersect with N D equal to yes. This is 0. So if you want to find probability of homeowner equal to no, given default equal to yes. So how are you going to do it? So probability of H equal to N intersect with H, D equal to no. Sorry, this is no, right? No and yes. Yes. Divide by probability of D equal to yes. Okay. So to find, this is the number of outcome intersection. So if you want to know what is the probability of probability of H equal to no intersect D equal to yes, this one should be equal to number of outcome H equal to no, D equal to yes, 3 divided by number of outcome in D equal to yes, 7. So this one should be equal to 3 over 7. 0 what? This is 3 over this is 3, right? So 3 over 3 lah. Yeah. Equal to 1. Okay. Right. Let's do for another one. Let's say you want to find probability of H equal to yes, given D equal to no. So what is the probability value? This one should be probability of H equal to yes, intersect D equal to no, divide by probability of D equal to no. Right. This is the same concept, we just apply into the data set. So this one should be H equal to yes, this one, and D equal to no, equal to 3. And number of no equal to 7. So 3/7. Right? Boleh? Right? So if you refer to the next slide, so I already calculate it for you. So I already table 2 by 2 table for homeowner and default borrower, and 2 by 3 table marital status and default borrower. And I calculate all the number of intersection and number of outcome. Right? Right. So if you want to find the probability of H equal to yes given D equal to yes, so we just take the number of intersection divided by number of this is based on the conditional probability. Okay, remember conditional probability, right? It's the same thing. I think you already know. Just to emphasize. Okay, this is for marital status. Right. So I take, if I want to find probability of merit and default default borrower yes. So we take the value of intersection merit and yes, divide by yes. D equal to yes. Okay. Boleh? This one okay? For categorical variable. Right. Just want to you to understand the first part. Now the second part, if we have a continuous variable, conditional probability. This method, we will apply this same method on linear discriminant analysis. So if you assume this is a this Gaussian distribution, we need to calculate the mean and standard deviation and find the value of probability of X given Y. So based on the formula of normal distribution. So this is a normal distribution formula. 1 over square root of 2 pi sigma is multiplied with exponential negative x minus mu square divided by 2 sigma square. Right? Let's look at this example. Let's say I want to calculate for continuous variable. We know that for continuous variable, right, let's look at this one. If the default borrower is yes, calculate standard deviation default equal to yes. So means that we take these three numbers 95, 85, and 90, right? Plus all together, divided by 3, we got 90K, 90,000. And we find standard deviation. So standard deviation is the observed value minus, so this is the formula standard deviation. Where is it? Oh, I tak letak. So x minus mu square divided by n minus 1. This is variance. So standard deviation means we need to take a square root of the formula. So here I take the value 95 minus 90, right? This is the mean. Right? This is also equal to mu lah, right? So mean square plus 85. So I forgot the term of sigma xi minus mu square. Right. So we will get the value of standard deviation, which is 5K, and the variance equal to 25K. This is for yes. And for no, you need to calculate all the value for no, obtain the value of X and standard deviation and variance. Okay. Then we input the value into the formula. If the annual income is 120, this is our X. right? And default equal to no. So we input into the formula. This is 2 pi multiplied with the sigma square. This is a basically wait, you will get 0.0072, right? And then we calculate for default equal to yes, right? So you input all the mean for yes and variance for standard deviation. Variance standard deviation. This is variance or standard deviation? Standard deviation variance, right? Variance for yes, and then we will get like 0.000 something lah. It's very small compared to the no, right? Okay, boleh? So what we have compute just now is probability of X given Y. So notice that default already at the back, given, right? So this one also default dekat belakang kan? So in order to find probability of Y given X, we need to compute this value, probability of X given Y. Now let's say we want to predict X homeowner equal to no, marital status married, annual income equal to 120K. And what is the classification of Y? Whether it's a default borrower or no default borrower. So as I said just now, the naive Bayes assumption, if you remember previous slide, naive Bayes assumption is assume that the class conditional to be independent. Means that we need to take a product of each X value. Okay. So first step, we calculate the probability of X given no, which is this is a conditional, class conditional. So H no and D no, M merit, D no, annual income 120, D no. So this is the first class, right? So we multiply all the product, the class conditional, we will get 0.0024, right? So we do the same thing for D equal to yes, right? We will get equal to 0. Okay. So then to find which class the value will fall, it means that homeowner equal to 0, marital equal to married, and 120. So we need to find probability of Y given X. So let's first we take the default value equal to no, Y equal to no, and the X value. So this one should be probability of no, right? This one, let's say I put this way lah. Probability of D equal to no given X should be probability of X intersect D equal to no multiply with probability of D equal to no. Right? Divide by probability of X. In this case, we don't know the value of probability X. Right? We already calculate this one. This is this is X given D. Right, so we don't know the value of x. We're going to set alpha equal to 1 over probability of x. Or we can ignore the denominator probability of x. Right. So now we just include the value, plug in the value into the formula. So we will get 0.0016 alpha. So we can basically ignore the probability of x here. Right. So then we calculate the probability of y equal to yes and given x. Right. This is equal to probability of x given d equal to yes, multiply with probability of d equal to yes, divided by probability of x. So the value of d x given y equal to yes is 0, right? So we calculate this one just now, right? Okay, this one we calculate just now. We just input into the formula. Probability of d equal to no. We take it from the previous calculation. We know that probability of no equal to 0.7, probability of yes 0.3. We include into the formula, then we will get the value. So which one is larger? So since probability of no given x is larger than probability of yes given x, so the observation will classify as no. So this is how an A-based classifier works. Okay. Any question? Hey, you want me to show or you want to do by yourself? So basically that's it for naive Bayes, right? Okay, so I think you can do it by yourself. This one, example number 5. Or you want me to show? Okay, right. Okay, kita tengok this one, example number 5. So example number 5, same concept. So this is a data set of buying a computer, right? So the class variable is buy computer. We have two label, either buy or no, yes or no, right? So we wish to classify age equal to yacht and income medium, student Y, credit equal to F. So now, what is the first step? We need to find the class conditional, right? We need to find a class conditional. So by default, you need to do a cross tabulation table, just as I showed before, right? Class cross tabulation table like this. I had to find the value of class conditional, but we try to focus on the objective, right? So let's look at the first one, y equal to no. So this is no. So since all the independent variable are categorical variable, so we can calculate easily by using cross tabulation table. So the total n equal to, what is the total n? 14, right? So probability of C equal to yes. Probability of C equal to no. So we have no 1, 2, 3, 4, 5. So 5 over 14. This is should be 9 over 14. Okay. So first we find probability of H equal to Y given C equal to no. Can you calculate? So we have 1, 2, 3. Should be 3 over 3 over what? The total number observation of C equal to no. So we have 5 observation, right? For Y equal C equal to no, right? So this one should be over 5. Right? Probability of H equal to Y given C equal to yes. Later on we will calculate this one. Right. Now we focus on C equal to no. The second one, probability of income equal to medium, C equal to no. Right. So medium 1, 2. So should be equal to 2 over 5. Okay. The next, we want to find credit rating. Rating equal to fair given C equal to no. We just focus on our objective. So this one should be 1, 2, right? So 2 over 5. The last one is probability of student equal to yes given C equal to no. So how many students? Only 1, right? So it should be 1 over 5. Okay. So now once we finish on C equal to no, we focus to the next part, which is C equal to yes. So we can erase this one. Right? So now, probability of Y, H equal to Y and C equal to yes. So this is 1, 2. Right? So it should be 2 over 9. Okay? Because we will have N C equal to yes equal to 9. And C equal to no equal to 5. Okay. Next, probability of income equal to medium. Is it medium? Right. Given C equal to yes. So how many? 1, 2, 3, 4. So 4 over 9. Probability of student equal to yes, and class equal to yes. So this one should be student 1, 2, 3, 4, 5, 6. So it should be 6 over 9. And last is probability of rating equal to fair given class equal to yes. So 1, 2, 3, 4, 5, 6. 6 over 9. That's all. So we have calculated the class conditional. So what's next? We want to predict age, student, income, and rating. So the value of x equal to age and come to and last is rating equal to. So this one equal to the product of probability of x given y, xi. So now we do it for credit score. Okay, so this is a bye-bye. Or y equal to yes, which is C. Right. So this one should be probability of xi given y equal to yes. So this one should be 2 over 9 plus 4 over 9 plus 6 over 9 plus 6 over 9. We just add everything on the yes part. So this one should be how much? 0.044. Can you calculate? Confirm my answer. And next, we need to find probability of xi given y equal to no. This is 3 over 5 plus 2 over 5 plus 2 over 5 plus 1 over 5. So this one should be 0.019. Is it? Right? Now we just calculate the class conditional. Now we want to find the probability of y equal to yes given xi. So this one should be probability of xi given y equal to yes, multiply with probability of y equal to yes, divide by probability of x, where we don't care what is the value of x. Right. So this one should be, so supposedly it should be like this, huh? But we don't care about this value and we can ignore this value because you don't know the value. Right. So now this one should be 0.044 multiply with probability of y equal to yes, 9 over 14. Is it? Yes or no? 9 over 14 is 0.643, right? So this one should be 0.028. And maybe we put it properly lah. So this one should be probability of x, and assume that probability of x equal to alpha equal to 1 over probability of x. So this one should be 0.044 multiply with 9 over 14, right? 9 over 14 multiply with alpha. So this one should be 0.028 alpha. And probability of y equal to no given xi, right, it should be 0.028. 0.019 multiplied with 5/14 alpha. So this one should be 0.007 alpha. Right. So which one is larger? Since probability of y equal to yes given xi is larger than probability of y equal to no given xi, so the x will be classified as yes. Okay, boleh? Simple, right? Simple but tedious. Okay. So this is the advantage and disadvantage of naive-Bayes classifier. Right, fast to train, fast to classify, not sensitive to irrelevant class features, can handle real and discrete data, and handle the streaming and data well. Disadvantage is it assume independent features. So because if you have very high dimensional data, if you're dealing with a genetic data, right, or any image data, means that you are dealing with high dimensional data, it's impossible to have independent features. Some features may be correlated. So this is the advantage, and this is different between naive Bayes and logistic regression. You can read by yourself later on. Okay, that's all for naive Bayes. Any questions?